Welcome, my dear students. In the third preparatory grade, we'll complete the answers of problem on the second lesson. Question number 6. A car moves at a speed of 54 km per hour. Then the driver used the brakes to decrease its speed to 36 km per hour in 2 seconds. Okay, the first velocity is 54 km per hour. We should convert it to meter per second. To convert it to meter per second, we should multiplying by 5 over 18. So the velocity by meter per second equal 54 times 5 over 18. It's equal 15 meter per second. Okay. When the driver used the brakes, the velocity decreases to reach its speed to 36 km per hour. So the final velocity of V2 equals 36 km per hour. So the final velocity by meter per second, we should multiplying by 36, okay, multiplying by 5 over 18. It's equal 36 divided 18 equal 1, divided 18 equal 2, 2 times 5, it's equal 10 meter per second. We observe the speed decreases from 15 meter per second, okay, V1 equals 15 meter per second, to reach its speed during 2 seconds. So the time is 2 seconds, okay, time equals 2. Its speed become 10 meter per second, okay. Calculate the time needed to stop. Okay, so the final velocity equal 0. V2 equals 0. Okay, but after period from its velocity 10 meters per second. Stop the car from the moment using the brake. Using the brake when the velocity was 54 km per hour, its meaning equal 15 meters per second. So this question, okay, this problem needed the time which is spent during stopping, okay, from this point to be stopped. From these values, the velocity, the initial velocity and the final velocity at the 2 seconds, the velocity become 10, okay, 10 meters per second. We can calculate from these given the acceleration of this object which is moved by it, okay, is moving by it. So the acceleration equal V2 minus V1 divided time. V2 equals 10 minus V1 equals 15 divided time, it's equal to. So the acceleration by negative because V2 less than V1. V2 equals less than V1. So the velocity equal negative 5 divided 2. It's equal negative 2.5 meter per second square. Okay. This problem need calculate the time needed to stop, okay, from using the brake. From this point, it's equal V1 equals 15 meter per second, and the final velocity, it's equal 0. We know the acceleration by negative 2.5, so we can calculate the time. The basic law, A equals V2 minus V1 divided time. Okay, so the time equal V2 minus V1 divided acceleration. Okay, so the time equals V2, it's equal 0 because it needs the stopping of the car, okay, it's equal 0, minus the first using the brakes, okay, it's the velocity was 15 meter per second, 0 minus 15 divided acceleration by negative, okay, time it's impossible to be equal 0. So the time equals by positive sign, it's equal negative 15 divided negative 2.5, okay, negative with negative, it's equal 15 divided 2.5 equal 6, okay. This object needs 6 seconds to be stopped, okay. We will answer question number 9. Question number 9, okay. A car moves at speed 18. A car moves at speed 18 meters per second if the driver used the brakes to decrease the speed. So it decreases by 2 meters per second square. Calculate its speed after 12 seconds, okay, from using the brakes. At the first, we can determine the given, okay, at the starting. A car moves at a speed 80 meters per second. So this is the initial velocity. V1 equals 80 meter per second. If the driver used the brakes, so the acceleration or the velocity decreases, its speed decreases, so this object or this car moves by deceleration. It decreases by 2 meters per second square. Meter per second square, it's meaning this is the acceleration of this object. Acceleration equal 2 meters per second square, but it said he uses the brakes, okay? So the acceleration by negative. Acceleration equal negative 2 meters per second square. Calculate its speed. It needs V2, okay? After 12 seconds, this is the time, equals 12 seconds. We can calculate the velocity or final velocity. The basic rule, A equals V2 minus V1 divided time. So A times T equal V2 minus V1 times 1. So V2 minus V1, it's equal A times T. We need the time, we need the velocity, final velocity. V2 equals, we should form V1 to the other side, okay? So V2 equals A times T plus V1 minus, it become plus. It's equal A, this is the acceleration equal negative 2 times time equals 12, okay? We form the multiplying, then we form the adding, okay? Velocity 1 equals 80. So the velocity 2 equals 80 minus 2 times 12 equals 24. It's equal, okay, 56. 56 what? Meter per second. We should observe the final velocity, okay, V2 less than initial velocity because the acceleration by negative. So the negative acceleration, its speed decreases, okay? This is the question number 9. Question number 12. Question number 12. Calculate the time required. Time, we need the time. Time required for moving an object at acceleration 4 meters per second square. This is the acceleration equal 4 meters per second square. Knowing that the change in the speed equal 28 meters per second. This is the change of velocity, it's equal delta V. Delta V equal 28, okay? The law of acceleration was delta V divided delta T, okay? So delta T or the time multiplying or exchange by acceleration and the acceleration exchange with the time. So the time equals delta V divided A. Delta V equals 28 divided acceleration, it's equal 4, okay? Changes, must decrease, okay? Calculate the time required for moving an object at acceleration, not deceleration, knowing that the change in the speed equal 28 meters per second. 28 divided 4 equals 7. 7 what? 7 seconds, okay? Question number 15. A car moves at a speed 60 meters per second, and when the driver uses the brakes, okay, to decrease the speed, so it decreased to 30 meters per second through 15 seconds. Calculate the time required to stop the car from the moment of using the brakes. At the starting, we can determine the given, okay, the first V1 equals 60 meters per second, and when the driver uses the brake to decrease the speed, so it decreased to 2, okay, so the velocity 2 equals 30 meters per second, its speed decreases through 15 seconds. We can calculate the time, it's equal 15 seconds. We can calculate from these given the acceleration which this car moves by, okay? Acceleration equals V2 minus V1 divided time. V2 equal 30 minus 60 divided time 15. It's equal negative 30 divided 15 equals a negative 2 meters per second square. This is the acceleration, okay? Calculate the time required to stop the car. To stop the car, so the final velocity equals 0. the car from the moment of using the brake. It used the brake when the speed was 60 meters per second. So we can put V1 by 60 meters per second. We know V1 and V2 and acceleration equals negative 2 meters per second. We calculate it, okay? We can calculate the time. Time equals V2 minus V1 divided time. It's equal 0 minus 60 divided negative 2. It's equal 30 seconds. Okay, the time shouldn't be by negative sign. Okay, simple, so it always by positive sign. Okay, question number 16. Within 2.5 seconds, the speed of car increases from 20 meters per second to 25 meters per second. Okay, this is the car. This car moves from the velocity, initial velocity was 20 meters per second. Then its velocity, V2, become 25 meters per second. This is during 2.5 seconds. This is the time, 2.5 seconds. We can calculate the speed, time V1 and V2, okay? While a bike moves from rest, it's meaning the velocity 1 of the bike, okay, equals 0. Its speed reaches 5 meters per second, so V2 equals 5 meters per second. In the same time, this is the time 2.5. Time equals 2.5 seconds, okay? Then we can calculate the acceleration of the car and the acceleration of the bike, okay? At the first, acceleration of car equals V2 minus V1 divided time. V2 equals 25 minus 20, divided time equals 2.5. It's equal 25 divided 2.5, it's equal 10. 25 minus 20, it's equal 5. 5 divided 2.5, it's equal to 2 meters per second square. The acceleration of the bike, okay, it's equal V2 minus V1 divided time. V2 equals 5 minus V1 equals 0 divided 2.5, it's equal 5 divided 2.5 equals 2 meters per second square. They are equal in its acceleration. Which one moves at a greater acceleration? They are equal in the acceleration. The first by acceleration 2 meters per second square, and the second, the bike, okay, moves by